Hello everyone. Today I want to talk about how we can program a star algorithm in C++ and actually a little bit explanation of a star algorithm that I programmed. I will add the link to the description, and you can find the full codes on my GitHub. So uh, before go in depth, I want to talk a little bit about the Astar algorithm itself. So in Dijkstra algorithm, when you move from the initial point, initial cell, the cost would be the distance from the initial cell. But in AStar, the cost function would be different, and you need to calculate the distance between, the current cell and the destination as well, and do the summation of the distance from the initial cell and the distance from the destination. So you can use different heuristic for this purpose, including Euclidean distance, octagonal distance, and like Manhattan distance, and so on. In this algorithm that I have implemented, I also considered the orientation of the robot. So, for example, uh, here, the orientation is toward right hand side or the east. So for example, if we want to move to the bottom sole, then the robot first needs to rotate toward the south and then move to this cell. Um, so the orientation is important in this case. And the result would be like this. So we have the full path. So in this example, that we have here, uh, the robot needs to rotate first. The initial cell is 2 4, and the orientation of the robot is toward east, so it rotates in its current location toward west, and then move to cell 1 4. And also the this method shows the full map of the grid cell, grid map actually. So you can see that the zeros are the obstacles. 3 is the final or the destination cell, and 2 is the start cell. 4 is the pass, so pass trace. So we can see that it moves from here to this location, and 1 is the free cells and unoccupied actually cells. So let's move to the code. I used C Lion to run the code. So we have like a main .cpp. So in main.cpp, let me run the code and just so it starts to get information from the user. What is the number of rows? 5, for example, by 5. And then it asks about the Euclidean distance method. So I choose, for example, the heuristic method, and I choose Euclidean, and then it asks about the please determine the number of cells x as obstacle. Just 2 would be fine for this example, and enter the location of each obstacles. For the location of the obstacles, as an example, 2 and 2, 3 and 3, and please determine the location of the start cell. So for the obstacles, we have a for loop, and then for the start cell, for example, 1 and 1. And also we need to determine the orientation. So for example, I choose like east, and then for the goal cell, 4, 4, and 1. So it shows the path. So here at the bottom of the code, we consider the user preference. So if we choose the Manhattan distance, then we need to um, choose the object Manhattan. So what is Manhattan, diagonal, octagonal, and Euclidean? These are some classes that inherit the A star class. So A star class has I define the A star.cpp, and inside it we have A star A star class. So it choose I will talk a little bit about this as well, but let's see the astar.h, which is the header file. So the astar class has like a virtual function, so we can override this function in the Manhattan, Euclidean, and octagonal and diagonal class. So it's an abstract class. So but inside it we have some helper function like is valid. So it checks that if the given cell is valid or not, and then is unblocked, so it checks for the obstacles. And then we have another function is destination to check if we reach to the goal or not. And then we have another function which is trace path. So it's actually the final function which prepare the output of the code. So I just briefly go to the AS star search. So this is the whole algorithm. So it start about from the check the cells that we suggested, and which we chose actually to see if it is valid inside the map and so on. And then here is think yeah here is the main loop in which we the while loop, in which we have an open list and actually close list, and checks all the successors, north, south, and rest. And yeah, so the other classes just change the calculate h value, or the heuristic method. And here's the result. For example, for this one we have like 1 1 east, 1 1 north, 1 2 north, and so on. And here's how the robot moves. So from 2, which is the start point, moves here and then like this to reach to the destination. So I just want to run it again and show you what if the if we choose the start location, for example, on an obstacle. So like 4 by 4, and then number of obstacles 2, it's 1 1 and 2 2, and then I choose 1 1 and 3, for example, and 4 4 and 3 as an example. So it says that, a start cell or the goal cell is blocked. So you check, the goal cell and start cell at the beginning. So yeah, so there are some other scenarios that, um, as an example, if we have 4 by 4 and choose Euclidean, and then determine the number of cells, just one, 1 3, and then I want to choose the start point, and then I choose 5 by 5 5 and 1 outside of the map. So a start cell is invalid. So the code check everything, and in this code, actually I chose just 4 successors, so you can move north, south, east, west, but in case you want, you can increase it to like 8 uh, with adding successors to the code. Yeah, so that's it. So I hope you enjoyed the video, and again I will attach the link to the description of the video, so you can have access. You have access to the the codes and enjoy it. Okay.